Hello, and thanks for clicking on another Narculus production. Yay! Today we're going to talk about everybody's favorite Frenchman, L'Hopital, and his rule in calculus. So let's get started. Here we go. So L'Hopital was a French mathematician in the 1600s. Okay. And what he did was he calculated limits in a brand new way, but he was only able to calculate limits that were of an indeterminate form. Okay. However, he was able to calculate limits in a different way than we have seen thus far. So let's see what he has in store for us. So if you remember back, we talked about indeterminate forms a long time ago, all the way back in chapter 1. Two really popular ones, 0 over 0, infinity over infinity, were both indeterminate. Okay, and you can see here how we would go about working out that limit. If we substitute 3 in, we would get 3 squared is 9, minus 9 is 0, over 0, 0 over 0, that's considered indeterminate. So we figured out WWA A1KD, right? What would an algebra 1 kid do? And the algebra 1 kid would factor the numerator and then cross them out and then evaluate the limit again by plugging 3 in, and they'd get 6 as their final answer, and that would be the correct answer, okay? So we did that back all the way in chapter 1. However, there's another way to do this that in many cases is actually a little easier, and in some cases it's pretty well necessary to try to do something algebraically, and that is with L'Hopital's rule. So L'Hopital's rule says the following, okay? If you have either one of these cases, the limit as x goes to a of f over g is equal to positive or negative infinity over positive or negative infinity, okay, of any type. So it could be negative over positive, positive over negative, positive over positive, negative over negative. All right. Or you have 0 over 0 as an indeterminate form. Then you can calculate the limit as x goes to a of f of x over g of x by calculating the limit as x goes to a of f prime of x over g prime of x. So basically what L'Hopital is saying here is he's saying that you can calculate this limit by deriving the numerator, deriving the denominator separately, and then going and evaluating the limit of what you just got after you found the derivative of each, the numerator and the denominator. Okay? But again, this only works if it's an indeterminate form, 0 over 0, or some kind of infinity over infinity. And we'll see that as we go along through the presentation today. All right? That's what L'Hopital has said. Okay? Now, here's an important note about the AP exam. If you want to use L'Hopital's rule on the open-ended portion of the AP exam, you must state that the limit yields an indeterminate form before you apply the rule. If you don't, you will lose points. Now, it's pretty simple. All you have to say is something like 0 over 0 is an indeterminate form. Is an indeterminate form. So L'Hopital's rule applies. This is really all you would have to say, something to this effect. All right. However, if you do not say this, you will not get full credit for the problem. Okay, because you're just using L'Hopital's rule without the initial condition of the L'Hopital's rule, which means you had to get 0 over 0 or some kind of indeterminate form, right? Just the same as when you're going to apply the mean value theorem. Right? You're not going to use the mean value theorem unless you tell me that the thing is continuous, the function is continuous and differentiable. Then you can use the mean value theorem. Same thing with L'Hopital's rule. Okay? You're not going to use L'Hopital's rule until you convince me that the limit is an indeterminate form. All right? Now, there are some things to really understand about L'Hopital's rule. L'Hopital's rule it's a simple concept, but it's a little bit complicated, more complicated than it may look on its surface. And it is a very convenient tool. There are some important things to know. So the most important thing is that L'Hopital's rule is not the quotient rule. Okay? You are literally deriving the numerator and then separately deriving the denominator. You are not using the quotient rule. Okay? Number 2, to use L'Hopital's rule, you must have a numerator and a denominator, both in terms of x or in terms of whatever the variable may be, before you can apply L'Hopital's rule. Okay? And of course, it must be in an indeterminate form as well when you try to evaluate that limit. And we'll see that later on during the presentation. All right. Number 3, if you need to use L'Hopital's rule, again, on the open-ended portion of the exam, you must state the limit yields an indeterminate form before you apply the rule. Okay, you cannot just go and start using L'Hopital's rule whenever you want. And that brings me to number 4. If you attempt to use L'Hopital's rule on a limit that is not indeterminate, you will get the wrong answer. Okay, you will get the wrong answer. So that's why it's important to look at number 3. All right, the idea that you have to show that it is an indeterminate form before you go ahead and use L'Hopital's rule. All right, very important. Okay, and there are some cases where L'Hopital's rule will not work. It will give you some kind of cyclical limit where you use the L'Hopital's rule, find a derivative, then try to evaluate, okay, and you end up back where you started again. All right, so you do have to be a little bit careful. Okay, so it's not the be-all, end-all. It's not going to solve all your problems in limit land. All right, so let's get started. Let's see how this works. So we're going to take the limit that we calculated earlier, and we're going to calculate it with L'Hopital's rule. All right, we did this one earlier using WWA1KD from Chapter 1. All right, so the first thing I would do is I would substitute 3 in, and if I do, I get 3 squared minus 9 over 3 minus 3. So this is going to be 0 over 0. 0 over 0 is an indeterminate form. So L'Hopital's rule applies. All right. Okay, so now we're going to use L'Hopital's rule. So let's come down here one step. We're going to find the limit as x goes to 3 of x squared minus 9 over x minus 3. We can do this by simply deriving the expression in the numerator. And if we do, we still have a limit here. Okay, we get 2x. And in the denominator, if we derive x minus 3, we get 1. And now we're going to evaluate this limit by taking 3 and substituting it in, and you get 6, which is the answer we got a while ago, okay, when we tried to do it algebraically. All right, so we get the same answer. Okay, and again, that's because we have an indeterminate form, 0 over 0. L'Hopital's rule applies. As you write across the line, the limit sign has to go with it. Okay, the idea that the limit as x goes to 3 of x squared minus 9 over x minus 3 is equal to 2x over 1, this is completely false. This is not true. It is not equal to that. It's equal to the limit as x goes to 3 of 2x over 1. Okay, that's what L'Hopital's rule says. So you do have to be careful. All right? Okay, so let's keep going. Let's see if we can make it a little more interesting. Here's one. Let's evaluate the limit x as x goes to infinity, e to the x over x squared, which is another limit we're going to be looking at here in the next chapter, the next video. So if I take infinity and I throw it in there, I get e to the infinity over infinity squared, so to speak, which gives me, I really shouldn't have an equal sign, but I get infinity over infinity, right? Infinity over infinity is an indeterminate form. So L'Hopital's rule applies. Okay, all right, so let's go ahead and we're going to use L'Hopital's rule on this. We are going to derive the numerator and derive the denominator separately. We have the limit as x goes to infinity. The derivative of e to the x is e to the x. The derivative of x squared is 2x. So now we are going to take infinity and we are going to substitute it in, and we get e to the infinity. That's infinity over 2 times infinity. That's infinity. We get infinity over infinity. That's indeterminate. So the question is, now what do? Well, we do it again, okay? Because L'Hopital's rule says we still have an indeterminate form, so L'Hopital's rule will apply. L'Hopital's rule will apply a second time. So let's go ahead and derive. The derivative of e to the x is e to the x. The derivative of 2x is 2. Now we're going to get a result. If I take infinity and I throw it in here, e to the infinity is infinity. Divided by 2, the infinity laughs at the divide by 2, and you get infinity. So the result is positive infinity. Okay, so you can use L'Hopital's rule more than once in the same limit. All right, that is valid. All right. Okay, let's try this one. This one's a little more interesting. The limit is x goes to 0 of x cubed times cosecant x. So if I take 0 and I substitute it in, I get 0 cubed, which is 0, times cosecant 0. Well, cosecant 0 is like 1 over sine, right? Okay, cosecant is like 1 over sine x. So that would give me 1 over sine 0. Sine 0 is 0. So really what we actually have here, and we can rewrite this here in just a second, and we can actually write this as x cubed over sine x. And if we get 0 cubed is 0, over sine 0 is 0, 0 over 0 is indeterminate. So L'Hopital's rule applies. Okay, and here's a perfect example of a limit where you must have a numerator and a denominator both in terms of x. Okay, because you can see if you try to evaluate this, take 0 and substitute it in, you're not going to get 0 over 0 or infinity over infinity, right? Because you have two things in the numerator, so it's not going to happen. All right, so now we have the limit as x goes to 0 of x cubed over sine x, and we're going to use L'Hopital's rule. So we're going to derive the numerator, and we get 3x squared. We're going to derive the denominator, and we're going to get cosine x. If we take 0 and substitute it in, 3 times 0 squared is 0. Cosine 0 is 1. 0 over 1 is 0. So my result is 0. Okay. All right. It's a pretty simple concept. Things like the chain rule still apply. All right. So let me just go back here 1 second. Oops. Oh, hold on 1 second here. Here we go. Gotta go back. There we go. Things like, let me just show you a couple things on the slide here before we finish up. So the chain rule still applies. So for example, if I asked you to calculate the limit as, let's say, x goes to, I don't know, x goes to 0 e to the 2x over x. Yeah, 2x minus 1, we'll say. You would get 1 minus 1 is 0 over 0. That's indeterminate. You could use L'Hopital's rule on it. So when you derive e to the 2x minus 1, you are using the chain rule. So it's e to the 2x times 2 with the chain rule. And the derivative of x on the bottom is a 1. And then I evaluate. I get 2 over 1. It gives me 2. Okay. And then also, just so you have seen it, okay, let's ask you for the limit as x goes to 1 of x squared minus 9 over x minus 3. So as x goes to 1, I can substitute this in. I get negative 8 over negative 2. The answer is 4 to this. Okay, now you can see if you try to use L'Hopital's rule on it, you'll get 2x over 1, and then you evaluate this, and you get 2. That is completely the wrong answer because the form was never indeterminate to begin with, so L'Hopital's rule never applied. Okay, L'Hopital's rule never applied. So you do have to be careful. You can only use this in an indeterminate form. All right, and that's pretty much all we have. So I just have 2 multiple choice questions for you to try, and then you're going to give me the answers to them tomorrow. Here's the first one. And here is, you can pause it if you want, and here is the second one. Okay, you can number them 18 and 19, and then I'll ask you for those answers tomorrow. All right, and as always, thanks for clicking.